Alrighty, so switch to the notebook. So we're going to continue on with section 7.2, trigonometric integrals. This is part 5. There's a lot of information for this section, obviously. So I've written down, a couple things from where we stopped last time. So we have two integrals that we're going to need for some of these examples. The first one is that the integral of tangent of x is the natural log of the secant of x plus a constant. You can actually, we've done this integral before. It's a u substitution. You write tangent as sine over cosine and go from there. The second one we need is this integral of secant of x is ln of the absolute value of secant of x plus tangent of x. For that one, I think you actually need you need a method that we haven't learned yet to actually do that. The book goes through a derivation, but they pull a factor out of nowhere that, lets you figure out that integral, but they don't really explain where they get the factor from. We're going to take these as granted for our cases here. So let's jump into the examples. So these are some examples where I can't use the tricks from the table in the book that I showed you. So the first example is we want to find the integral tan cubed of x dx. And the good news for this one is, any step I'm going to take here is really the only logical step there is to take. So if I want to integrate tan cubed of x dx, the first thing I'm going to do is, I can't do anything with that. No u substitutions, nothing with integration by parts looks promising. So I'm going to write it as tan squared of x times tan of x dx. And again, this is really the only thing that there is to do. Now, the only thing there is to do that changes it is rewrite tan squared. So I know that tan squared of x plus 1 is equal to secant squared of x. So this comes from the identity sine squared plus cosine squared is equal to 1. Divide both sides by cosine squared, you'll get this identity. So I'm going to replace that first tan squared by secant squared minus 1 tan of x dx. So if I distribute and break this up into two integrals, I'm going to get tan of x secant squared of x dx minus the integral tan of x dx. This second integral I've written down the formula for. It was one we've done before. This first integral we're going to have to do a u substitution. So I'm looking for something, and I want its derivative to appear there also. So I have a tangent here. Derivative tangent is secant squared. That looks to be the best u there. So I let u equal tan x. Du will be secant squared x dx. And now I just do the u substitution. So this is the integral u for tan x. Secant squared dx is du. So this is u du minus the integral. Well, so this integral I already know. It's the ln of the absolute value of secant of x. Now I'm going to integrate the first term, u squared over 2 minus ln of the absolute value of secant of x. Because I've done all my integrations, I get an integration constant. And I don't want this in terms of u, I want it in terms of x. So this is tan squared x over 2 minus ln of the absolute value of the secant of x plus my arbitrary integration constant. This one, again, you kind of have to play around with it until you get something that you can work with. And that's not uncommon in integration. It is just a lot of, especially these problems, playing around with identities until you get something that you can use. So let's move on to another example. So this one is the integral of secant cubed x dx. And for this one, so this one's not, so this one is, it's going to be a little different. And we're going to have to use integration by parts here. So for this one, I'm going to let u equal to secant of x. And then dv will be all the stuff that's left. So I've separated, so what I'm doing is I'm separating this into the integral of secant of x, secant squared x, dx. So if u is secant of x, dv will then be everything that's left, secant squared x dx. du, derivative secant is secant tangent. I'm going to give myself a little more room here. So du is secant x tangent x dx. If I integrate du, so if I integrate dv, integral of secant squared is tangent. And now I do integration by parts. So this integral is now, is u times v. So I get secant x tangent x minus the integral v du. So I'm going to get secant x tan squared x dx. And okay, this doesn't look very helpful yet, so let's keep going. Secant of x, tangent of x. So what I'm going to do now is I'm going to rewrite this as secant of x. So tan of x is secant squared of x minus 1. So this is secant of x, tangent of x. I'm going to split up this integral. I get minus the integral of secant cubed x dx plus the integral secant of x dx. Okay, and now what you should see is I have this integral again, which is the integral I'm trying to find. So I have, so what that means is, the integral, what that means is the integral of secant cubed x dx. So that's what I've started with. And that's going to be equal to all this stuff. That's going to be equal to secant of x, tangent of x, minus the integral secant cubed of x dx, plus the integral secant of x dx. So if I move this to this side, I'm going to get 2 times the integral secant cubed of x dx is secant of x times tangent of x. And now this integral secant of x is going to be, well, I've written it down up top, ln of the absolute value of secant of x plus tangent of x plus your arbitrary integration constant. So what I get then is the integral of secant cubed of x is 1/2 secant of x tangent of x plus ln of the absolute value of secant of x plus tangent of x plus my arbitrary integration constant. You'll see that this one is a little more complicated. You have to do a little more work. You have to use that trick where we go through and solve for the integral that we're actually trying to find. So I have one last example to show for this section. So it's one that doesn't fall into any of these things, and it just kind of highlights, you kind of have to be clever and remember a bunch of your trig identities for this. So this integral is the integral of sine of 4x cosine of 5x dx. And for this one, we are going to use an angle addition formula. So if you Google, trig formulas, you have that the sine of A times cosine of B is equal to 1/2 sine of A minus B plus sine of A plus B. So what I can do is I can take this formula sine of 4x, or so I can take this integral, sine of 4x cosine of 5x. I can write it as the integral, and I'm going to replace this with 1/2 sine of a minus b, so 4x minus 5x. Just get a minus x there. And I have a plus sine of a plus b, so 4x plus 5x is 9x dx. I'm going to do two simplifications here. I'm going to pull the 1/2 out in front. And now sine of minus x, sine is an odd function, so I can pull minus signs out of it. Odd functions are where f of minus x is equal to minus f of x. Let's pull, so it just says you can pull minus signs out. And now these integrals I can do. This is 1/2 integral of sine x. So integral of sine x is minus cosine x. Minus sign in front makes this cosine of x. I'm going to integrate sine of 9x. Again, it's a u substitution if you want to do it that way, or if you're getting good with this, you can do that in your head by now. And then, of course, your plus c. And that would be our final answer there. So again, with these, they're a little harder. You're going to have to do a bunch of them, just get a good feel for them. They are difficult, but once you've done enough of them, it is clear what to do. So I'm going to stop there, and that'll be the end of section 7.2.